Hello dear students, welcome to Pen and Paper Chemistry on YouTube. The topic that we are going to start today is electrolysis, and we are going on to part 1 where we shall be covering basic definitions related to electrolysis. We shall be talking about electrolyte, non-electrolyte, conductor and electrolysis. No, don't go away. Don't think that these are definitions that I know, because in this video I am going to stress upon certain terms what we call as the key terms which affect the definition, the explanation, and of course what we all are aiming for, marks. Because if you miss out those key terms, then even though you may have written the definition, you do not get marks for that. So let's get going. Electrolysis. Electro comes from the word current, lysis, breaking down. So when electric current causes the breakdown of a substance is what we will call as electrolysis, right? Now you have, every day you see there is, you are watching this also because of the current that is there in the charge that is stored in your mobile, and that happens through charging through a point, right? Now the current that is coming to your home is through copper wires, right? So are copper wires electrolytes? Is electrolysis happening there? Think about it. Do they undergo a chemical change? No, they don't. If they were undergoing a chemical change, then you would have to probably replace those wires every few days or every few months, right? So let us define electrolysis how it should be. Before we go on to define electrolysis, we need to distinguish or differentiate between two terms, conductor and electrolyte. Just now I gave you the example of current coming to your homes through copper wires. That's an example of a conductor, right? Whereas when you talk about electroplating of articles, you have silver spoons, you have gold plated articles. That is happening because of the solution being an electrolyte. When you are talking about copper wire, the current is flowing through a substance in its solid state, right? So we call them as conductors. I have left it as a blank for you to write examples. Like silver is a very good conductor. How do we know that it's a very good conductor? Yes, it will allow the electric current to pass through it, and if you connect a silver wire and you connect a bulb to the terminals of a battery, the bulb will begin to glow, right? Another simple thing, you touch silver, it feels cold to your hand because it is a very good conductor. It draws heat from your hand. That is why you feel cold, right? These are simple observations that you can make in order to connect science to your daily life. Electrolyte is a substance which again conducts electricity, but either in its molten state or in its aqueous solution form. So, if I have pure distilled water, this does not allow the electric current to pass through it. Pure distilled water, no current passes through it. So, it is not an electrolyte. But as soon as you add a few drops of acid or alkali to it, immediately it starts conducting electricity. Hence it is an electrolyte. So the key terms over here are the molten state or aqueous solution. By the way, there's a small question or food for thought that I have left for you at the bottom. Can you devise a way to determine if a solution is an electrolyte or a non-electrolyte? By the way, what do you think would be the definition of a non-electrolyte? If you know the definition of an electrolyte, you will know non-electrolyte. You just have to add one word. Go ahead, pause the video, start writing the definition yourself, and you will see that you will be very, very happy when you will be able to write the definition yourself. Believe me, the confidence, with one definition, how it grows. Let's check. Substances which do not conduct electricity in molten state or aqueous solution are known as non-electrolytes. Another question for you. Find out examples for me. At least 5 examples. Right? I've given you only 2. You see, there should be some work to be done on your part as well. It gets boring if I just keep on giving you information. So find out 5 examples of non-electrolytes for me. That means the substance is either in the molten state or the solution form, but still it is not conducting electricity. Yes, you have the pure distilled water. It's already there on the board. Think of some more examples. So what happens when you pass electric current through the molten state or aqueous solution form of a substance? You have done in your previous classes, where we know that electrolysis of acidulated water gives you 2 gases, hydrogen and oxygen, right? 2 gases are formed. So what has happened is, water has broken down. It has got electrolyzed to give you 2 gases, hydrogen and oxygen. In other words, water has undergone a chemical change. So what is electrolysis? The breaking down of a substance on the passage of electric current through its molten state or, very good, aqueous solution. There you go. Now you can't get wrong with these definitions at all. They may seem simple, but if you lose 1 mark only because of one word or term, it pinches a lot. I can relate to that a lot. So make sure that you pause this video and write these definitions yourself. It is very easy to hop from video to video. The content matter is the same. The way it is delivered may be different, but the content remains the same. Now it's your part of the job to learn it yourself so that you can teach it to your classmates. Teach part 1 and come back for part 2. So you become a teacher further on. Happy studying to all of you.